Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1 and today's same chapter sequence and series. But today's topic is Cauchy root test and Leibniz test. So in this lecture we will learn about these two tests one by one. So first start with the Cauchy's root test. This test is also so easy like a ratio test. Okay, so have a look. If sigma un is a series with positive term and limit n tends to infinity un raised to 1 by n. Because of this power 1 by n, that means nth root, this test is called a root test. Okay, so nth root is written as this. As we know that if I am writing square root of n, that means x raised to 1 by 2. If I am writing x cube, that means cube root of this. And same way, if nth root of x is written as x raised to 1 by n, so this is nth root, that means it is root test. Nth root of un, that given series nth term, which is also L, and same condition as ratio test. If L is lies between 1 and 2, 0 and 1, 0 and 1, 0 included, then series is convergent. If L greater than 1, series is divergent, and if L is equal to 1, test fail. But here this is not its concept is not available that the root test is failed and we will apply Leibniz test. No, Leibniz test is totally different from root test. Okay. In previous lecture, if root fail, then we want to apply Rabelais test. But here there is no any conclusion about that. We have to check for the different any test. Okay. So this test is applicable, or you can see directly in the question, if your un is given in this form, in power form, power of n, then compulsory root test is helpful to you. Okay, so let's understand with 2-3 example of this root test. First example, test the convergence of sigma n running from 2 to infinity 1 upon ln, that is log n whole raised to n. Here you can see that this power n is given, only power, not factorial. If factorial is there, we will use compulsory ratio test, but only power of power, okay, anything raised to n, then we will use root test. So here solution is, we have un is given, so un is this, we will take nth root on both the side, so un raised to 1 by n, so this whole raised to 1 by n, so n cancel out, so we have log n. Now apply limit on the both the side, so we have this limit and limit. Now if we put n is equal to infinity, 1 by log infinitive, that is undefined, and 1 by undefined is 0, and I told 0 included, okay, not less than, okay, we cannot say less than, but 0 included in test. So if we get L is equal to 0, then by root test given series is convergent. So simple. But you have to observe that whole raised to n power is given, n or n square or n raised to anything according to the example. Okay. One more example to understand better. Here n into e raised to n. Okay, now we have to just check if it is convergent or not. So let's start with the un. This is un by taking nth root on both sides. So un raised to 1 by n, this raised to 1 by n. So we have this n cancel out, and this 1 by n goes to this power n. So we have e outside, because of this n cancel out, and e n raised to 1 by n is as it is. Now we know this will give us 1. Why? Because n tends to infinity. That means infinitive raised to 1 by infinitive, this is 0. Anything raised to 0 is 1. Okay. So e into 1, or how? So we know the standard series. Standard limit. So e into 1, and this e is greater than 1. So by root test, given series is divergent. Okay. So one more example, test the convergence of this. Now Pause the video and find out the nth term of this series. What is the nth term? Try by yourself so you can understand better. Okay, here it is observed that, let me allow, here observe that 1 cube, 2 cube, 3 cube power is fixed, and in denominator base is fixed, 3 raised to 1, 2, 3, 4. That means 1 1, 2 2, here base, here power, here base, here power. So we have n raised to 3 upon 3 raised to n. Okay, so this is our un. We will apply 1 by n. So this whole raised to 1 by n. So this 1 by n goes to numerator as well as denominator. If we will apply on the denominator, the n cancel out. So we have in denominator n, and here n cube raised to 1 by n. That means n raised to 3 by n. So by applying limit on both sides, and 1 by n goes to the numerator and denominator. So we have this term, and by simplifying, as we have just seen, if this limit apply on this term, it gives 1. So we have answer this 1 raised to 3, that means 1 by 3, which is less than 1, by root test, given series is convergent. Simple. Okay, so these are the example based on a root test. So last 5 tests are more important. Which are the 5? Comparison test, ratio test, Rabes test, root test. These are the 4, and final one is Leibnitz test. These are the 4 most important tests that you have to keep remember in your mind. Okay, let's start with the Leibnitz test. Leibnitz test is also known as alternating series test. That means if the given series is alternating series, then and only then we can apply this Leibnitz test. Otherwise, we cannot apply Leibnitz test. So, for Leibnitz test, we can directly, by observing the question, we can say that this example is of only Leibnitz test. Okay, how? After understanding the steps. A series is called alternating series if its terms are alternatively positive and negative. Alternative, as its name, it is given positive, negative, negative, positive, negative, positive. Starting with negative or positive doesn't matter, but if we start, then all compulsory it is alternatively negative, positive, or positive, negative. Okay, and for example, like this: plus, minus, plus, minus, plus, minus, plus, minus. Okay. So, if series is alternating, then we will apply Leibniz test. And what is Leibniz test? If the alternating series, this, and alternating series is directly by observing this term, minus 1 raised to something, or by observing this plus, minus, plus, minus, plus, minus, plus, and so on. Okay, and its nth term, that means this term is always positive. Okay, other than this minus. So by observing this or by observing this, we can say this is alternate series. And if it is alternate series, then satisfying following 2 conditions, then we can say that this given series is convergent. Number 1, that un plus 1 is less than un. What is the meaning of this for all n? That means each term is numerically less than its preceding term. Each term is numerically less than its preceding term. Each term is numerically less than its preceding term. Because as we know, we have that u1 and we have u2. So this term is less than its preceding term. That means this. Similar way, u3 is less than its preceding term. Similar way, this. That means we can say that is a decreasing series. Okay, and alternating is already there. But here numerically less than. What is the meaning of numerically less than? That means you have to check this only u1, u2, u3. Don't include this plus minus sign. Okay, otherwise it cannot be possible. So we have to ignore this plus minus sign, and you have to just check the that term only, numerically less than this numerical term only. Okay, and number 2, if this is already completed or already checked this term, that each term is numerically less than its preceding term, then we will find the limit of un, which is 0, then given series is convergent. And if this is not equal to 0, then given series is oscillate. Okay, so this you have to keep remember these two condition. Okay, so let's understand this alternating series and how we can check the each term is numerically less than its preceding term. Same like we already checked for decreasing and increasing. Okay, you can check by direct or you can check by this also. Each term is numerically less than its preceding term. Okay, so for that you have to check this. This minus this is greater than 0, or you can say that un plus 1 minus un is less than 0. Okay, you can check this or this. So you will get this, and this you will, if you will get this, then you can say that each term is numerically less than its preceding term. So by Leibniz test, we have to check the limit for un only. Okay, so let's have an example. Here, by directly you can see, you can say that this is the example of Leibniz test because of minus 1 raised to something n. Okay, so this by observation, this is alternating series and its un is given by this. Other than this term, I told you this is our 1 upon log of n plus 1 is un. Now we will check that each term is numerically less than its preceding term. For that, we know the log x is increasing function, so log n plus 1 is less than log n plus 2 each term, because increasing function only log. But if we take reciprocal, so inequality will be changed, and we know that this is our un, so this is our un plus 1. So here it is clear each term is less than its preceding term, so we will apply limit for the un. And if we apply, so we have 0. So by Leibniz test, given series is convergent. So simple. So last 5 tests, this is 5th test, are most important as well as so easy. Just you have to keep remember all the concept. Okay. One more example to understand better. We have this series and we have to test the convergence of this series. So first we will find the nth term of this series. It is clearly nth term of this series is given by this alternate series. It is already given the plus minus. We can say by observation. So this is written as minus 1 raised to n minus 1 into 1 upon n into root n. That is, if we put n is equal to 1 into root 1 is 1 into denominator 1. And if we put 1 here, 1 minus 1 is 0, minus 1 raised to 0 is 1 plus 1, so it is plus. If we put 2, so 2 minus 1 is 1, so minus 1 raised to 1 is minus, and 2. Similarly, if we put 3, so 3 root 3 and 3 minus 1 is 2, so minus 1 raised to 2 is plus, and so on. So this is our un. Now we have to check that un plus 1 is this. So as we know that this term is less than this term, and by taking reciprocal, this un is greater than un plus 1, or as I told you can check by this logic also, un minus un plus 1 is greater than 0. So you have to take difference, and this is always positive. So this can say that each term is numerically less than its preceding term. So we will apply limit on un, that means apply limit on this un, and n tends to infinity. 1 by infinity is 0. So by Leibniz test, given series is convergent. Okay, so these are the basic example, DIYs, do it yourself by root test, that is Cauchy's root test and Leibniz test. And from this, out of this 7 example, here you can say directly this is Leibniz test because minus 1 is something, plus minus Leibniz test. 6 number is also Leibniz test because of this minus 1 is to n, and 7 is also Leibniz test because of this plus minus. And these are the 3 example of Cauchy root test. Because of whole raised to n, as I told, n or n square or anything raised to n. Okay, so these are the practice example. Always use not and pen, then and only then you can understand better. And if you understand, or if these are the basic all the tests in your mind, then you can solve next last two lecture. Okay, so to understand last two lecture, you have to revise all the 8 lectures, starting from 1 to 8 lectures of this chapter. So thank you for watching. Keep watching, keep learning. We will see you soon with the next lecture of this chapter. Thank you very much.